Alright, so let's get down to business. Let's get to the real reason why I actually bought this truck. As we all know, this is a 1988 Jeep Comanche with a wonderful 2.5 liter in it. They're not very powerful, they're not good for a whole lot, but their diagnostic business works a little differently than the 4.0s. So I kind of need the hands-on stuff in order to experiment and actually get the thing to work. So today's video is going to be a little scattered since it takes a lot of thinking and poking around to actually get anywhere. But we're going to see if we can crack the 2.5 liter diagnostics. So come for a ride and hopefully I can make some sense of all this stuff. So there's a couple things we need to figure out. One is the hardware required to actually interface with this thing. And then second is going to be the software side of just figuring it all out. Now, I got to poking around with the Snap-on scanner and the software, and it looks like it is very, very similar to the 4.0, so that's good. That makes it a lot easier for us. So now, what we really got to do is figure out what these pins do and how to get the data out of them. So let's go find us some diagrams and start poking around, I guess. The main goal is pretty simple. First, we need to figure out where the data is at, and then second, we need to figure out what kind of hardware we need to do in order to get our high and low signals, because that's all we're after. We're after ones and zeros. A 1 is a logical high, or a high voltage of something, and then a low, a 0, is just a low voltage of something. So in the 4.0, a high, we get a ground signal, and a low, we just get a floating pin. So with a pull-up resistor, you could do whatever logic level you wanted, so we do like 5 to 0 volts. So that's pretty easy. So for this one, we just got to figure out what it does, and then we can get our beautiful pixies. Okay, so just to run you through this whole mess right here, we've got jumpers to go from the diagnostic connector to our MT2500 over here, and you'll see that we have our data. So basically I plugged them all in and then kept unplugging until we have the bare minimum. So we have our negative, our positive, 1 and 2. If you unplug either of these, the black or the green, the data goes out. So we need 7, 4, 1, and 3. 7 to 1 is good, 7 to 3 is 0. And 1 to 3 is also data. So I got this guy running. So basically it's just the Arduino, run an analog in, serial out, and we can use the serial plotter and see data. Cool. Okay, so now I guess I'm going to hook up our logic analyzer and see if we get anything out of it. Alright, so now we're here with the logic analyzer, still connected same way between pins 1 and 3. And we've got the numbers! Yeah! Yeah! So we're hooked up to 62,500 baud, and I can set this to inverting, so it'll invert the signal so it'll read it properly, and we've got numbers! Yay! So this will still need the regular transistor inverting circuit, but we've got stuff. I dig it. Cool. Alright, so to continue progress, the Comanche is not my house. That should make this a whole lot faster. Alright, so back to what we were doing. So we got the battery charged up, and we've been messing around. So this is our bare minimum. Like I said, we need pin 1 and 3 for data, and we need ignition and ground for the device to come on. Now, something that I want to test. First off, I check the continuity between 3, which seems to be our ground signal, and our regular ground, and we have about 50 ohms of resistance between them, but not enough to be considered continuity. At least it doesn't pass the beep test. So now what I'm going to do is connect the positive and negative for the scanner, hook it up to a 9-volt battery, and see if we still get data. So if we still get data, then we know for sure that this should be the place where the current gets sunk. Okay, so we get a jump to the 9-volt battery. Now over here we get waiting for module to communicate with the scanner. So the ground signal is important for some reason. Interesting. So there's not continuity, but we still need that ground as well. Okay, so the ground wire is also necessary. So we got an alligator clip on the ground that goes over to report, but we're still powering the device off the battery. So with it powered off the battery, we do get our info. So we need the ground, pin 1, and pin 3. I still don't know what the heck's going on here. This is so weird. Okay, so now we got our Arduino Uno set up with the serial plotter so that we can watch this thing kind of like a bootleg oscilloscope. So we are grounding it to the vehicle ground. And we're just going to take our probe and poke a boot. So if we go to pin 1, you notice we get data anywhere from, if I can keep it still, it should be 1 volt to 5 volts. Now if I move with still ground as our reference, and I go over to pin 3, we don't really get anything. We kind of just get interference and, okay, there we go. Alright, so we get perfect ground. So now what I can do is make pin 3 our reference ground over here, and then plug this into the other ground. Okay, so we got ground signal again. Now we take our probe and put it on pin 1, and again we get data from about 1 volt to 5 volts. So that's interesting. So do I just connect the circuit as usual but hook that up to ground with maybe a resistor or something, or what? Because there is 50 ohms of resistance between there. Maybe it's a pull down resistor? I don't know. This is very strange. Okay, so now trying to test what this thing actually does. I've been pulling the pins so that way it's monitoring what the snap-on scanner does, but not what the diagnostic port does. So if we are ground referenced and we pull pin 1, we get 5 volts. If we're ground referenced and we pull pin 3, then we get 0 volts. So it seems like pin 1 is our 5 volt signal, pin 3 is our ground signal, and ground is also our ground. But for some reason, we need ground and pin 3 to do the job. So I don't know what the heck's going on. I don't know if pin 3 is like an ECU ground only or something, and then it needs to go back to regular ground, or I don't know. It's very strange and very annoying. I don't like it. Okay, so I've broken out the trusty factory service manual. So if you come down to here, this is the 2.5 liter diagnostic connector. So if we take ourselves a gander, you notice pin 1 and pin 3 are what we're after. And for pin 1, that's the serial data for auto. But if it's a manual, then it's the upshift indicator lamp. So I don't know why on earth they decided to change what the pin was going to be depending on what kind of frickin' transmission was in there. It's rather annoying. Then if we come down to number 3, if it's an auto, it's the park neutral. But if it's a manual, then that is our serial data. So this gave me an idea. This confirmed what I kind of already knew, but here's the confusing part. I figured if everything's pulled up to 5 volts by itself, so if we come over here and we test all these pins, right? We bring up our little Arduino, get the serial plotter going. Okay, so we check everything, right? It's 5 volts. So first I figured, alright, well, if we're getting a high signal, then we need to make it low. So we need some kind of pulled down resistor. So I figured, oh, well, if the data is coming out of 3, if that's the serial thinger-dinger, then we want our doohicker on 3, and then maybe mess around with 1, but I didn't get anything. So I noticed that there was like a 50 ohm resistance between ground and 3. And, you know, first I tried, when the pin we're looking at was on 3, I tried like a 1K resistor from 3 to ground, and the signal dropped from 5 to 0, but we didn't get anything good. And then I tried the resistor from 1 to ground, didn't get anything good. Tried from 1 to 3, still nada. Okay, so now we move on. So now we're back on pin 1, but if we take Mr. 1K resistor and put it between 3 and ground, okay, look at that. We get data. Yes. And if we pull the resistor, 5 volts. Would ya freaking look at this? That's all it was. So I don't know what the heck is going on here. All I know is that it works, though. Holy macaroni. That is amazing. So, I guess the next part would be we could break out the Windows laptop and see if we get any data with a simple available command to see if it's inverting or not. Nah, we'll just get the logic analyzer and do it the fun way. Okay, so we got Senior Logic connected, and right now with our little switch we have 5 volt signal. Okay, so now we take resistor and plug it in, and then we'll check again. Light please, thank you. So we'll plug that in there. Okay, now we'll run it again. Hopefully, hey! Okay, so here's an interesting fact. Don't worry about channel 1 and 2, that's just interference because they're plugged in. So if you'll notice, our lines are low, our idle line is low, so that means that we will need to invert this in order to get good data, so we will still need to run this through a transistor to do that. But the cool thing is, in this guy, we can invert right here. Look at that. Look at that, oh boy. We got the data, boy. Yeah. Look at that, huh? Oh no. Well, some of it was good. Looks like we're getting interference. Yeah, crap. Well, we're on to something. So we definitely got something. But it's weird how these things are spaced. Ugh. Interesting. The interesting thing is, this is data that I pulled off the Snap-on scanner. So I had the logic analyzer just hooked straight in next to it. And I noticed from our 1 to 7 setup, like what we have here, I was getting glitches every now and then. So let's see if I can find one. But it does have that weird spacing to it too. That might be one right there. Yeah, see? This little glitch right here set it off, and then it read in properly. So for some reason from 1 to 7 was giving us issues, but if we come down and check, I think this one was 1 to 3, so we still get that weird gap bite. It's strange that they just kind of mosey on out like that. But I don't believe there were any framing errors if we come down this list. It all looks very happy. Come over here. This one, we got some weird stuff. Okay, so the next idea is that maybe I don't have the right ohm resistor. So if I measure with the scanner on from ground to pin 3, it's 83.3 ohms. So I'm wondering if maybe something to like a closer to like 100 ohm resistor might do what I want. So maybe the 1000 ohm is just a little too much. So let's try a smaller resistor and see what happens. So with the 100 ohm from ground to 3, we get data. Now I turned off the other channels so that way that's not interfering. And if we come over here, I don't see any framing errors. So hopefully we are good. I'll have to give it a real good once over, but I don't see any messed up bytes. So I think we're in. Okay, so now we're dicking around with the REM. So I thought I had the circuit figured out, that it did the pulling up and down by itself, and it was running off pin 1 when we pulled pin 3 down with a 100 ohm resistor. Well, that didn't do nothing. So this has a pull-up resistor in it for the base, so I unsoldered that, and still nothing. Okay, so I start poking around, and the logic analyzer will read data from pin 1 to 3 or from pin 1 to 7 when 3 has the resistor to ground. But when I hook the REM up, we don't get anything like that at all. It's just constantly brought, I think, low. Why you no come? Alright, so I'm just going to say screw it. We're going to pull the ECU and see if we can't trace anything out. So first what I'm going to do is verify the connections that my diagrams have from the diagnostic connector over to the other side of the ECU. And if you're curious where the ECUs are at, come under the dash, and there she is. Ta-da! Renix. Excellent. So, first what you're going to do is pull this panel. Generally, you'll have to take screws out to do this. Mine come pre-disassembled. And now we can get a much better look at what's going on in here. So it looks like we got a bolt there, and probably a bolt hiding somewhere else. So I'll take this bastard out and see what she's doing. Oh my god. Well, at least the Renix factory spider webs are still installed, so that's nice. Okay, so you got a bolt way the heck up there in the top in the corner in the stupidest frickin' location you could think of. Then we got another one down here on the bottom, and then the easy one has the slide on it. Why the hell does the easy one have the slide on it when you can't frickin' slide it? Harbor, harbor. So I don't know if I can even get you in there, but that one, is that it? Focus. Oh, excuse me. That's one right there at the bottom, and then the one at the top is, I probably can't even, oh, there it is. Ta-da! Yeah. How the hell are you supposed to get that one? Good frickin' look. Oh my god. What a fucking genius. Okay, you can come out now, please. Hello, Francois. How are you doing? Wonderful. Okay, so now we just gotta get this connector dector off, and she should be free. Okay, so this is gonna take some toolios, but basically we have a lock and we have a tab over here, a little tiny one. And what we do, get yourself a nice flathead and pull this tab back enough to let that other tab free. So you pull this back, it frees, and then you rotate it and it falls right out. Beautiful. Come here, you bastard. The doctor will see you now. Alright, so we just got a Torx T10 on each corner, and a janky little metal cover. Slide right off. And would you look at this bad boy? Look at how clean it is in here. It's like a time capsule from the 80s. It's incredible. It looks beautiful. Cool. So I guess I'll try and do some pinouts and figure out where the important stuff is. Then we can get an idea of the circuit. Alright, so now it's time for things to get serious. So here we have the 2.5 liter ECU all set up, and alligator clips galore. So we have ourselves a 12 volt power supply down here. So that puts out about 13 some volts and 2.5 amps max. I found out the fuse was blown in it, so I had to jump it with a 5 volt fuse instead. So we got all that run into here. So we got our two black lines on the left, and then our two positive lines. We have the power and the ignition right there, and then we've got everything for the scanner over here. And if you take a gander, she actually freaking works. Ain't that some shit? Looky there, huh? And you notice all these readings are 0 because, well, nothing's hooked up. But that's what you would expect. And the voltage actually works. That's cool. So, yeah. That's a go. So that means that now we could start poking around, I guess, and see what we find in here. somewhere over here in Mr. Big Chip Land is where I think our data's hiding. So somehow we gotta figure out what this motherfucker does to get the numbers. Okay, so here's the tech lab right here. I've got the Photoshop file up that I was using to map all the wires and all that stuff. And then down here we have Arduino sketch running just an analog read. So when we touch things, it'll show us stuff. And then we just start poking around on the board. So if we come down to this pin down here for the scanner, you notice we get data, which is cool, but it's got those little bottom glitches, which are a little weird. If I come to the other side of that, this diode is connected to that, and you notice from that diode we don't get any of those weird bottom things. So it's weird. I didn't think that there was anything in between those two. It should just be a wire connecting those, but I don't know. If we go farther down the line to this big looking chip thing, to the center pin, that is the next part that it connects to, and we do get data there. And the one foot seems like it's a ground, and the other foot seems like it's going to the main IC, which we were looking for. Now my little wire came apart, but it is the wire right here, I think. It's one forward of that capacitor leg. And that one shows us an inverted signal, which is what we're expecting. It is a high that drops low. So I guess that this thing is some kind of transistor thingy that actually drops the signal low. So that's something. So that means that this should be able to sink current. Should. It's even got a diode on here, and I even did a diode check, and the diode is going forward. So either there is a trace somewhere that I didn't quite pick up, or some other funny business is going on here, because I don't see how. Well, I'd have to unhook everything and take a look, but I don't know. We do find data on that pin, so that means that I did map that out properly. So that's cool. So that's that one right over there, that pink one. That's our data. Alright, well, I guess I'll keep dicking around. I might unhook the scanner next and then see what is different. Okay, so to try and save a lot of time and not bore you quite so much, I'm going to show you the final, what I figured out. So, first off, the most important thing was I was using a voltage divider on the analog read to make sure that the signals were below 5 volts. Once I figured that out, I got rid of the voltage divider so that we could see if our pins were floating or not. Because the problem with the voltage divider is since it goes to ground, it'll always read close to 0 even if nothing's there. So it's hard to tell if it's actually being grounded or if it's floating and it's being grounded by the resistor. So by running it floating, we can get a much better picture of the signal. On the left column, we can see what the signal looks like with the MT2500 hooked up. And then on the right, we can see what it looks like when it's not hooked up. So by comparing what's happening with the scanner on with the scanner off, we can see where the data is and what's happening to it. So the IC pin is the important part. That's where the data is coming from. So without the scanner, it's just going to ground. So it seems like it's syncing. Now with the scanner hooked up, we can actually see that it goes high. So it goes high, and then the IC pin is probably bringing low. Okay, so that's interesting. Next we'll move to that big transistor looking thing. So we'll notice that the signal is now inverted. So our idle line, instead of being high, which is normal, it's inverted and reading low now. The signal's low and then it goes high or whatever. Now with the scanner not hooked up, that's floating. So that is very interesting. That means that the scanner is doing something to this pin to make it do what it's supposed to. And the same on the other side of the diode. We'll notice that it looks about the same, but the low voltage seems to be a little bit higher, and that probably has something to do with the diode. There's probably a diode drop in there, and that's what makes our low higher. And this is going to come into play later, so remember that. And again, on the other side, it's floating. So what it looks like is that our snap-on scanner is providing a 5-volt signal or something like that. Now, the other one is interesting. D23, with the scanner hooked up, it's at ground, and when there's no connection, it's 5 volts. So this one, it looks like our scanner is bringing this to ground. So by bringing this one to ground, and with it unhooked later, I tested on D2.1, it does provide 5 volts. With those two in combination, we finally get our signal. So now that we can see what's going on, let's figure out if we can get the Arduino to read it properly. So here's the transistor base. You notice it's floating. Now, first off, let's see what happens if we ground 3. So we're taking that 5 volt signal and we're grounding it. You notice now we get ground and some little bit of something or other. So that's interesting. So I'm going to disconnect that. And now, let's see what happens when we supply 5 volts to D1, which is reading floating. So now you notice it goes high. So now we have our high and we have our low. So when we put them together, so that's the 5 volts already, so let's ground it now. Look at that. We get something. It looks awfully like something. Cool. Okay, so real quick, I just want to show what's going on here. So this is the ECU running with everything all hooked up. This is our pin. So if you notice, we don't have a perfect 0, and that is going to cause us issues with our transistor because it keeps us constantly open. So we need one that closes a lot higher. Ugh. Because if we come over here, right, so we got all this hooked up, and then we ground that transistor, look at where it sits. Interesting. Unplug it, it goes back to whatever. So we don't have a low enough low for that transistor to shut off. So we can't invert the data. Interesting. Okay, so this is the final setup that I think we have figured out. So our main data line is focus. Our main data line over here, D2.1, that is our TX line. That is the diode that goes into the transistor, fun things, and does the IC. D2.3 over here, this green guy, it's a 5 volt signal, and you have to ground it in order for D2.1 to do the other half of the switching. So you ground this guy, and then we use this and this as our data. So we have our ground as well. So basically, ground and D2.3 are just connected together, and then D2.1 goes to our TX pin. But we're not done yet. A couple things we got to do. First off, the data is inverted, so we have to re-invert the data. I'm just using an NPN transistor to do that. So you feed it into the base, and when it goes high, it sends it to the ground, blah, blah, blah. And then you have a pull-up resistor to fix that. But that's not the entire story, because if that was the entire story, then technically we could just use our current system and be good to go. But for some reason, the ECU, its low is not 0. It's like 1.1 volts. So the problem is that is not low enough to turn the transistor off. So the low and the high keep the transistor high, so the transistor never inverts. It just sits there open all the time. So what I have now is a voltage divider. So we have our 3.3K signal, right there, which is the pull-up, and then we have a voltage divider that goes to ground so that we get the proper highs and lows for the transistor to switch, and then the transistor does all the other fun stuff. Okay, got our ECU resting in there. See what happens. See if anything blows up. If everything works, we should see numbers. Oh fuck yes, oh fuck yes, oh fuck yes. We've got them. Excellent. Very, very good. Okay. Now I'm not sure why it updates in like fucking pulses or whatever. But yeah, that's sweet. Righteous. Okay. Well, since we got that, we're good. So I'll have to modify a connector, and I might modify my alpha REM and see if we can read this 2.5. Should we get this sweet? Alright, here it is. The moment we've all been waiting for. So, I got a V3 adapter over here modified. You just notice we got a jumper. Got a jumper from 3 to ground. And then, in this old alpha model over here, I did a little funk diggery. So I bent the transistor back and then hooked up the two resistors we need to make that voltage divider. One to ground, one to the signal, and then they both go to the base. And then I changed the program number that this thing searches for to the 2.5 liters so that it should be able to track the stream. So if everything's good, this should work. Well, there goes nothing. See if it don't blow up on us. Oh, fuck yes. Look at that shit. Oh, baby, the data comes on. That means we're solid. Oh, yes. Oh, man, we're going to get rid of that. Fuck yeah. Alright. So, I know that a lot of these readings are correct for the 2.5 and the 4.0. They share the same thing. So check it. If we move the throttle position sensor. Hey, mommy. Yeah. Pretty good. Cool. Fuck it, I guess now we gotta start it. Fuck yeah. I'll have to see if the idle has to be calibrated though. I mean, it could be idling at 300. Possible. Rest in pieces, monsieur. Cool, but things moved. So that's the vacuum reading, air intake, RPM. Now the voltage is off by half, so we just multiply that by 2, I think. So that's what, 12.6. The O2 is going to be wrong too because this is only like 0 to 1 volt. And then a bunch of other things I have to check and see if they actually go to the same place. But holy crap. Wow, it actually works. We did it, baby. Oh yes. Alright, so now we can watch what this thing's doing. I guess I messed up the injector formatting a little bit, so I'll have to look into that. Notice the RPM's pretty low. Looks like it's in closed loop though. Let's see if it starts doing the dumb idle thing it was doing. Now the oxygen sensor seems like it's working properly. Sorta. Oh, now it's getting a little funky. So now it's like trying to richen it too much. Before it like wasn't. Before it was trying to lean it out. Oh, there it goes. Okay. Rip. Okay, so I just had the logic analyzer hooked up to the REM to check everything out. The data seems okay. So this is with the engine running off. Or this is with the engine off. So you can come in, see our wonderful bytes. And we've got like a byte gap, somewhere around 0.8 milliseconds. But they also vary. Sometimes they're closer, sometimes they're farther. Now if we go over to the running side, you notice there's gaps. We're talking like 7.5 millisecond gaps between like, you know, just a group of data. Everything else is about that 0.8. So it's weird that when it's running it sends it in chunks. Because the screen actually updates so fast you can actually see that hesitation. So I was curious if it was like reading funny or not, but that's interesting. Well, that's something to keep an eye out for. Everything else seems okay though. Yeah, I don't know. But hey, we got data. Cool. And most of the math seems to be pretty spot on now, so. Alrighty, so if you stuck around for this long, I think it's time to finally wrap this all up. So, we figured it out, and we got it to work. Awesome. So, just to wrangle this in, right over here is our final circuit. So just to show everything off, over here is our diagnostic port with everything labeled. Over here is our transistor, which is used to invert, and then over here is the Arduino stuff. So all the lines are labeled and everything's figured out. So, in order to power the Arduino, number 4 is our ignition source, so that just goes to the VIN pin in the Arduino. And the ground pin is number 7, so that just runs down here to all of our ground stuff and into the Arduino ground. Now, for the main TX line, the TX first gets pulled up by 3.3K resistor, so this brings the line high, and then the stuff inside brings it low. So that gets us our initial switching. But in order to bring this down low enough for the transistor to switch, we use a voltage divider. So we have a 4.7K here and a 2.2K to ground. So with this voltage divider, now the transistor can switch properly. Now, in order to get the signal to fully switch, we also need to ground this pin. Number 3 needs to be grounded. I don't know if there needs to be a resistor here or not. Right now I'm using it without a resistor and it's fine. But I feel like maybe I should whack in a 50 ohm or something like that just to be safe? I don't know. I'll have to look and see if the signal changes at all with a slight resistance and if it's worth it. But anyway, so we have our inverting circuit here, so this inverts the signal. And then in order to read it, all we need is a pull-up on the collector side. You can put a 1K in or just any kind of, general resistor. Or if this is going to be a short distance, like it's on the same board and everything, you could just use the pull-up line on here. So just tell it to use the internal pull-up on the Arduino, and you can take that resistor out because it'll already bring the 5 volts. So this brings it to 5 volts, and then if this is good, and we actually get current in here to switch the transistor, now it'll go to ground, so it'll bring the line low. That's pretty much it. So you get your pull-up for the ECU, voltage divider, inverting transistor, pull-up, Arduino. Simple as could be. And in case you're curious what that looks like in real life, that's just what we got going on here. We have our pull-up resistor, we have the 2 things for our voltage divider, our transistor, and then it goes to the RX pin on the Arduino. Now as for math and stuff like that, I'm going to keep this kind of short and simple, but here is the big old hoopla doobity blah. So all the lines that are light gray are the same. Okay, so all the light gray are the same for each one. The dark gray, the byte still means the same thing, but there's different math. And if it's white, then that means that it's completely different or in a different location or something like that. So a lot of the stuff is similar. First off, the AC is moved, so we're used to the AC request being down here. Well, now it's like number 2 or 3 or something like that. And the throttle switch is also thrown in there, so it's taken from here. The throttle switch moved from there to there as well. And then the clutch and EGR share that one now. The injector has also moved, and it's split into 2, so this is a 16-bit instead of the 8-bit normal. So that's got some combination math. And besides these just have slightly different readings. The voltage, instead of being 0 to 16, is 8 to 16. The O2 is like 0 to like a little over 1 volt. And the RPM, you have to multiply it by 1.5 in order to get the right speed. So besides that, everything else is pretty much same from the 4.0, so a lot of calculations that we use work fine. So yeah, change up your math a little bit, and you're good to go. So, I hope you've learned a lot. I sure have. I've learned that this stuff is a royal pain, but man, is it nice when you finally figure it out. Goodness. So, hopefully I can build all this into the next model for the REM V4s, so we can have 2.5 liter reading right off the bat. And I want to add some kind of system that will automatically ground our pin for us. So if we can ground the pin when we need it, and then not ground it when we don't need it, then we're solid. And this voltage divider circuit over here, you can still read the 4.0 with it, so that's not a problem, but you will have to change that ground pin, I think, because otherwise the coil to the battery positive latch will be always on or something. I don't know. I'll have to look into that. But yeah. Okay, well, thanks for watching. That's all for now. Hopefully your brains didn't blow up yet. Quick shout out to the Renix Power Group on Yahoo. You have to get accepted to get into here, but, you can ask questions about your Renix stuff and things like that. I found a lot of cool technical people on here, So I was bouncing my ideas around on there, and eventually I was able to figure it out. But they were definitely trying to help me out, so that was really cool. So shout out to that group for some pretty interesting stuff. Never know what you'll find on there.